Today we are discussing about third module, that is flexibility metrics method of analysis. So what is flexibility as well as what is stiffness? These are the two technical terms to start with. Flexibility means it is basically displacement itself. So it is a displacement produced due to a unit force. That is, when we apply a force at any point, the displacement produced is called as flexibility. The condition that the applied force should be a unit force. Okay. Now stiffness. Stiffness is force required to produce unit displacement. That is, you applied some force and that force resulted in a displacement. And that displacement is equal to unity, then the force which you applied is called as stiffness, represented by K. So flexibility's equation is delta by P or theta by M. Theta by M meaning is that theta is slope. Displacement can also expressed as slope when we apply the force as moment. Yes. Next is, what are the basic idea of flexibility method? We have learned about force method of analysis. So flexibility method is another name of force method of analysis. We studied in structural analysis 1. Right, we studied different methods. One of the method is consistent deformation method. So in this method, the primary unknowns are forces, and we will find out the unknown forces using different conditions. What are the conditions? We apply equilibrium conditions to find out forces. If there are more number of forces, equilibrium equations are not sufficient to find the unknown forces. That condition is called as redundancy or indeterminacy. So in order to solve the additional forces, what we will do, we will apply compactability condition. And using that compactability condition, we will solve the unknown forces. We have studied in the consistent deformation methods and other methods in our SA1 class. Right. So here we are using a matrix method to solve it. That's the difference. So this is a basic formula connecting relationship between displacement and forces. There is a term flexibility. See, displacement is equal to flexibility into force. R, capital letter R represents a force, small letter r represents displacement. Now the physical approach. In the third module as well as in the fourth module, we will follow the physical approach. The basic idea is that we will analyze the structure and find its unknown forces, unknown displacements, stress, strain, etc. as a real structural behavior. That means we are analyzing the structure in its real properties, finding what really happens to the structure. So in such a behavior, the idea is to find out the material properties, how these material properties will influence the behavior of the structure, as well as is there any relationship between forces that exist or the relationship between force and the displacement that is produced. One such a relation is we discussed here, the relation displacement and the force is being connected by a matrix called as flexibility matrix. That means it is directly proportional. If I apply 10 kilonewton force and it produced 10 displacement, then if I apply 20 kilonewton force, it might produce 20 displacement. That may be proportional in such a way. So there are relationship between force and displacement. Such all behavior we study in the physical approach. So coming back, the structural versus elemental approach. That means in the slope deflection method or in the consistent deformation methods that we studied in SA1, we analyzed the structure as a single unit and found out the displacements and slope at a point. But in matrix method, what we will do is we will split the structure into small units. That is, see, this is a single I section beam. But while analyzing the structure, what we did is we split it into small sections and analyze each element separately. This is the basics of finite element method, and matrix method is one such a pioneer for that. So similarly in matrix method, we will split into small elements and analyze the elements separately and apply the boundary conditions. So what is element approach? It is a micro approach, divides the structure into small finite sub-elements, analyze force, displacement, specific behavior strictly at the localized element level. That means it is called as local coordinates. We also call it as local coordinates. And here we will call it as global coordinates. Global coordinates. Matrix method, flexibility, stiffness method, finite element method are all example for element level approach.